All right, so section 11.6 deals with adding and subtracting rational expressions, right, which still follows the same rules as adding and subtracting fractions. Right? So if our denominators are like, right, which in order to add and subtract, we do have to have like denominators, or common denominators would be a more common term that you might have heard. So if we don't have a common denominator, we have to create one. But once we do have a common denominator, to add, we add the numerators and keep the denominators the same. To subtract, we subtract the numerators and keep the denominators the same. So if the denominators are already the same, it's pretty simple to add them. Right? Even though 3y over y plus 5 plus 4 over y plus 5, we have y plus 5 and y plus 5 as our denominators, so we have common denominators. So we can add the numerators, 3y plus 4, which those are not like terms, so we can't combine them. They're just going to be separated by the addition. And we put that common denominator underneath them, 3y plus 4 over y plus 5. And that's all there is to that one. Next one, n minus 3 over 2n minus 3 over 2n, common denominator. So we know the denominator is going to be 2n. And on the top, we're subtracting the numerators, n minus 3, and we're going to subtract 3. So n minus 3 minus 3, it gives n minus 6 over 2n. And since this n is in a subtraction, we can't simplify the n's. Just going to leave it there, n minus 6 over 2n. Now, the next one, we have 1 minus x over 2x squared minus 7x plus 5 plus 3x minus 3 over 2x squared minus 7x plus 5. Common denominators. So we can go ahead and combine those. 2x squared minus 7x plus 5. And on the top, 1 minus x plus 3x minus 3. Combine those together. Negative x and 3x is going to give us 2x. 1 minus 3, negative 2. Over 2x squared minus 7x plus 5. Now, just like anything else, if we can add them and then we simplify the fraction after we're done adding or subtracting. 2x minus 2 over 2x squared minus 7x plus 5. We can't really tell if we can simplify, so we need to go ahead and factor those down if they can, especially when we see an x squared. We know that we won't probably need to factor that. So 2x squared minus 7x plus 5. It's a trinomial, a quadratic trinomial with a 2 in front. So we're going to do the a times c method. A is 2, b negative 7, c is 5. So a times c, 2 times 5 is going to be 10. We look at some minus plus, so both factors are going to be negatives. And factors of 10 that will add up to equal negative 7, negative 2, and negative 5. All right, add those together, they equal negative 7. So, in order to factor those, we make those into fractions. Negative 2 over the a term, which is 2. Negative 5 over the a term, which is 2. Negative 2 over 2 becomes negative 1 over 1. build our binomials. Denominator in front. So 1x minus 1 and 2x. All right, the denominator in front of the x, followed by the numerator, minus 5. So x minus 1, 2x minus 5. And if we look at the top, 2x minus 2, both terms have a 2, so we can pull the 2 out of those two, which 2x divided by 2 leaves us with x, and 2 divided by 2 is 1. So x minus 1 and x minus 1, those are going to cancel out. 2 on the top, 2x minus 5 on the bottom. Alright, so those were adding and subtracting when we had a common denominator already. If we look at this next one, 5 over 3x cubed plus 7 over 6x. We do not have a common denominator. But just like when we had just regular numbers underneath there, we've got to get to where they have the same thing on the bottom. So our denominators are 3x to the third and 6x. So 3 can become a 6, right? We can multiply that by 2, get 6x. And in order to go from an x to an x cubed, we would have to multiply this one by x squared. So what we're actually looking for our common denominator is going to be 6x cubed, basically combining these two. Right? 3 can become 6, and x becomes the x cubed. We can't usually go smaller. We've either got to get bigger or stay the same. So to get 3x cubed to be 6x cubed, we would have to multiply that by 2, right? And to get 6x to be 6x cubed, we'd have to multiply that by x squared. So if we look at 5 over 3x cubed plus 7 over 6x, we have to multiply the 5 over 3x cubed, the whole fraction, by 2. Because whatever we do to the denominator, we got to do to the numerator. So now we have 10 over 6x cubed. And for 7 over 6x, we said we had to multiply that by x squared, top and bottom. So 7x squared over 6x cubed. Now we have common denominators. We can add. We got 6x cubed on the bottom and 7x squared plus 10, or 10 plus 7x squared on the top. Alright, so then the next one, 2x squared over x plus 1 minus x minus 1 over x. So our denominators we're dealing with are x plus 1 and x. Now, in order to get a common denominator, we can't add things to the denominators, we have to multiply. And so I can't make this x into x plus 1, and I can't subtract the 1 to get that to be an x. So basically what I'm going to have to do is I'm going to end up with x times x plus 1 as my denominator. We're just going to multiply those two together to get a common denominator. So that means that I multiply this one by x plus 1, and I'm going to multiply x plus 1 by x, right? So 2x squared over x plus 1. X plus 1 has to be multiplied by the x, so the top has to be multiplied by x as well, which is going to give us 2x cubed over x times x plus 1. And we're subtracting from that x minus 1 over x, which that part of the equation has to be multiplied by x plus 1. And x minus 1 times x plus 1, that's a sum and difference, which we can multiply those. We can FOIL them if we want to, or we know that it's going to fit the pattern of the first term squared minus the second term squared. So x squared minus 1 squared, which is just 1. Over x times x plus 1. So we're subtracting that. We have a common denominator now. X times x plus 1 on the bottom. And we've got 2x cubed minus x squared minus a negative 1, which is going to become positive 1. And that is what we end up with, which actually looks bigger than what we started with, but that's how it works. So that's section 11.6.